This conference will now be recorded.
Hello everyone, I'm very glad I can greet you on additional webinar from the DigiFoF webinar series. Today we'll have very interesting topic, rapid implementation of cobots in industrial environment, and our presenter today will be Christian Mihuchoiu from Continental, and the slides were also prepared with support of Cosmin Moga, who is also joining us today. Before I give the presenter rights to Christian, one technical topic. As in the case of previous webinars, we are using GoToMeeting, GoToWebinar platform. So if you have any questions during the session or afterwards, make sure to expand the GoToWebinar and GoToMeeting panel. And there you have a chat option. If you put something in chat, we can work with this, and I can pass the questions to the presenter at the very end of our session when we'll have Q&A part. When you're asking questions or using chat, you can select whether this will be something visible for all participants or is it only visible for presenters. So if you wish, you can also send the private chats and private questions. So this is for the technical aspects. And now, without further ado, I would like to pass the presenter right to Christian, who will tell you more about the content of the presentation and will present everything. So, Christian, floor is yours.
Hello, everybody. I'm glad to have you here and we present you this topic. Just a moment. Okay. So we'll talk today about rapid implementation of cobots in industrial environment. It's a short presentation where I will show you some facts and figures about what happened in our plant. So the presentation is made based on our experience in implementing cobots in Continental plant in Sibiu, Romania. The content of the presentation is made of several elements. We'll talk about general presentation of the cobots, then we'll talk how to select the cobot for your application, then we will enter in some detail related with mechanical installation, grippers needed for the cobots, electrical installation, and a few details about the software of cobot. We will not enter in details about how to program the robot to do a specific task or how to use the software of the cobot. We'll just make some general details show about this. Mainly the cobots are some devices or equipments which are able to perform some tasks in collaboration with people. That's why we call them collaborative robots. Are considered as being complex machines which are able to work with the human operator to perform similar tasks, to work on the same environment or similar environments. Usually in a shared work process, they support and relieve the human operator. The cobots mainly is used to take from the human operator the repetitive task that, as you know, can create health problem to the operator. Repetitivity is one of the major causes of, let's say, professional disease. Cobots are specifically designed for working with people in the same shared workspace. Collaboration is determined usually by the application and the space, not the robot itself. Broadly, we have three categories of robots. When we talk about this, you remember that we have industrial robots, typically operates in cages because the forces and the let's say, dimensions of the material that they manipulate are quite high, quite strong. So it's a real danger for the robot. The robot is a real danger for the operators. In this case, that's why we keep the industrial robot into the cage. Then we have the second category, which is the cobot or collaborative cooperative robot, which typically interact closely with the humans with lower payloads, can be fixed or mobile. And we have the third category, which we do not talk now, which are the software bots that are application performing some very clear defined task, very detailed task, like downloading a report from SAP or from ERP systems. We'll not talk today about the software in details. When we talk about the cobots and we compare them with the industrial robot, we identify, let's say, the strong points of the cobots. The main good point for the cobot is the safety of the interaction. The cobot is made from design in such a way, it's let's say built with sensors, with all this the power that is required in such a way that the safety of the human working with this cobot to be not in danger. Other good point or a strong point of the cobot is the simplicity of programming. It's very intuitive. The programming of a cobot is very intuitive, and sometimes you are able to show the movement. You guide the cobot with your own hand, and the cobot remember the movement and can duplicate the movement. So it's quite easy, the programming. Plug and produce, it's also one good issue for the cobots, because you just install it, fix it on the floor, plug into the power, and then you can start to use it. There are not specific or very strong requirements related with installation from this point of view. Flexibility of the robot is one. It's also one of the good points, which is coming from the easy changing of the program in the memory of the cobot, or it's coming in the easy way or easiness of changing some parameters, changing one program in order to perform a slightly different task. Compared with the robots, industrial robots that we see previously, the cobot has also some not so strong points related mainly with payload. The cobots are not able to manipulate great or big pieces with heavy pieces. The reach, the distance that the cobot is able to move is not so high also. Main advantages of the cobots, as I said, it's safe interaction with humans. This one is one of the major advantages of the cobots. This advantage is coming from integrated sensors, from passive compliance systems designed built in into the cobot, in overcurrent detection. The cobot sometimes is built with cameras that can identify obstacles and are able to move around the obstacles in such a way that will not cause any harm to the human operator that it's working around. Easy programming, as I said previously, very easy to learn, to make the cobot to learn a movement just by guiding him, guiding the arm with your own hand, and then putting the cobot to repeat this movement. Flexibility of task is one of the advantages of the cobot, is coming also not only from possibility to change the program, is coming from the easiness of changing the tool at the end of the robotic arm, which give the possibility to reuse the robot, to take it from one part, move it to a different line, change the tool, and just start to use it. As I said, cobots are coming with some limitations. One of them is lack of ability to detect abnormalities, which make them less flexible compared to the human colleagues at this moment. Using machine learning and artificial intelligence, this point can be improved in time, and we know companies that are already working on it. Cobots have a limited operating speed. If they are forced to work to a higher speed, mechanical damages can appear, and you will need to do some maintenance work on the cobot and reduce payload and reduce reach distance of applications. So it's suitable for small parts, not for heavy parts, and for small distances like moving one part from one machine A to machine B, let's say no more than 1 meter between these two machines in order to allow the usage of a cobot. Here we see some forms of human-robot collaboration, starting with the collaboration when the robot has his own workspace and he's put into a cage that in case you open the door of the cage, the robot is stopped, which is the, let's say, minimum collaboration, or at least almost no collaborations. Going to different possibilities to share the workspace until this complete integration, complete collaboration, where the human and the cobot share the same workspace. The people can give a piece to the cobot or can take the piece from the tool of the cobot. So they are moving on the same space, the same area, and there are enough safety precautions, enough safety elements that do not allow the cobot to hit or to damage the damage to or to create problems, health problems to the operator, to the human operator. In terms of human-robot collaborations, enables variable automation of tasks for which complete automation is too expensive or too complex. And in this way, we can do this partial automation using cobot and leaving the other part to the human operator. So at the end, the cost will be more affordable for the company instead of doing a complete expensive and complex automation. There are combining rational tasks by combining strengths, dividing the work optimally between the robot and the human. The idea is that none of them wait for the others, wasting the time. Non-ergonomic workstations can be improved by the cobots. This is one very good, very strong point in terms of implementing the cobot. We remember that in industrial environment, there are a lot of posts where the operator must do the same task, pick and place, with very high repeatability. We have in our plant sometimes machines that operate with a cycle time below 30 seconds, even below 20 seconds. So in 1 minute, the operator must manipulate 3 times a piece on the same way. So for the, let's say for the fatigue, for the impact on the health of the operator, this is very dangerous. So in this case, using a cobot there will improve the productivity of the line and will release the operator from these repetitive tasks. Common applications. There are several common applications. This list is not complete. Definitely there are possible other applications, but there are some with them which are really common. Pick and place is one of the most frequent application for the cobots. The cobot just take the piece from one part, from one end of an equipment, from a conveyor, from a box, and put it in a different place. You can put it in a fixed position on a device on a tool on a second line or a second equipment, uh, always the cobot pick the piece from the same place and place it on the same position. So the position of picking and placing are quite fixed and standard. Machine tending. Here we talk about cobot loading and unloading a machine, or an application. It's loading a CNC milling machine, loading a 3D printer, or something like this. This type of cobot application may require to have an input-output interfacing hardware with the specific machine. So the machine, when the machine delivers the part in the specified position, it's calling the cobot to take the piece or to supply the piece for it in order to this way the machine, the CNC, call the cobot when it's needed. Another application is the packaging and palletizing. It's a specific application of pick and place. And why is this specific? Because if you remember, when you put boxes on a pallet, usually there are more positions there. So the cobot must to iterate the position. He put first, if we have 5 boxes to be placed on the pallet, he must to put 5 in the same layout as is in the programming. So he must put the first box, then the second box near the first, the third box near the second one. So in this case, he need to iterate. It's the same on packaging. When you have like a box with beer bottles, you need to put row by row of beers into the box in such a way that the cobot not to try to put bottles on the same row already filled with bottles and to create accidents. Another common applications, we can see it frequent in the automotive industry, is the process task. When the cobot has at the end as an effector uh, uh, a hose to deliver some glue or to deliver some silicone, or if you remember from the automotive industry, that robots or cobots using welding devices at the end of the robotic arm. So they just need to follow a specific track, a specific trajectory uh, with the end of the effector in such a way to perform that task, to deliver a specific quantity of glue or silicone, or to allow the parts to be welded together. In this case, we have this process task. We have another applications that we see sometimes is the finishing task. The cobot use a brush and he need to put some pressure in order to uh, clean or to polish some surfaces to eliminate the dust or to improve the shine of the surfaces. In this case, the cobot need to be supplied with force sensing, or he needs some cameras in order to identify which are the areas where he need to do this movement of polishing, or to identify areas with scratches to remove those scratches by polishing, or things like this. Another application that we have for cobots is the quality inspection. It's one not so frequent, where at the end of the robotic arm you put a sensor or a device measuring something or doing some verifications. These end effectors are supplied with end camera resolution, with sensors of all these elements in order that the cobot to be able to do the inspection. The cobot move the camera around or close to a surface in order to identify scratches, or the cobot move the let's say a sensor that can identify if there are holes or there are defects to a certain surface of a piece or something like this. In this case, the end effector is quite high in terms of capabilities, and Cobot need to be well programmed in order to be able to manipulate the sensor and also to transmit the data collected by the sensor or by the camera to the computer to make the quality inspection. Now let's talk about Cobot selection. There are some definitions that we need to see before to go next steps. Payload, here we talk about the weight that the robot can carry, and here the real payload, it's made from the uh, nominal payload without the payload of the effector or the gripper. So when you plan that the robot need to manipulate 1 kilogram, you must remember also that the gripper has his own weight, his own mass. So altogether, these two, the gripper and the load, must to be into the nominal admitted mass or restriction in this term of the Cobot. Reach is the distance that the robot can achieve. Usually the Cobot do not need to be forced at the maximum of the reach, because in this case there are some risks that are introduced. This measurement is taken from the robot base until the maximum distance that the effector can reach. The end effector, which usually we call it gripper, is the tool which is mounted in the end of the robotic arm in such a way to allow the Cobot to perform the task for which we install it there. The exact nature of the device depends very much on the application where we need to use it, the Cobot, and also depends on the Cobot itself. In terms of Cobot selection, in Continental CBU and also in Continental Worldwide, Universal Robot is the standard supplier for Cobots. It was made an evaluation of different Cobot supplier at corporate level, and the decision was taken to use Universal Robots as a standard application for our plants. Degree of freedom, it's also very important let's say selection rule. Depending on the complexity of the Cobot movement or other restrictions that are facing on the shop floor, an increased number of degree of freedom must be required. Speed, also it's very important, because based on the speed the Cobot is able to perform in a specific cycle time the movement that he must to perform, the task that it must to perform, in such a way that if the speed is not adequate, you will see the Cobot will become bottleneck for the line, and the productivity and the output of the line will decrease. Safety is one of the major elements. Sorry?
So this is yeah, sure.
Yes?
I
Okay.
think that Andrea by accident unmuted.
Okay, no problem. We are talking about safety. Safety depending on the project and how the Cobot will interact with the human operator.
Christian, I'm afraid I don't hear you. I'm afraid I lost you.
There will be no incident in the collaboration between human and Cobot. Here we have let's say a description of a Cobot UR5 from Universal Robots. It's a Cobot that is the most frequent in our plant, in CBU plant, because based on all these requirements, we decide to use this Cobot for most of the tasks that we wish to transfer from human operator to the Cobot. Now, let's see what is made of this UR5 Cobot. We have three elements: the robotic arm, control box, and teach panel. Robotic arm, it's composed of 6 axes. Sorry, he's able to move on these 6 axes. Has a modular design, so some elements can be transferred from one to the other one, and has a 360 degrees freedom, so he can perform a complete rotation around for all his elbow and wrists. The control box contain the flash card, the USB with software. The control box also supply the power to robotic arm, contain the safety systems and all the communication devices. As the connectors, we have the power connection. So as you can see, the Cobot do not require special power sources. Need the connection with Ethernet, USB, and also connection to the robotic arm. Teach panel or the touchscreen monitor contain the power button, emergency button, free drive, and USB connector. We'll come later to talk about these elements. The power button, by pressing the power button of this front of the panel, from the touch screen, the control box will be turned on. When the control box is started, the text will appear on the touch screen. After about 1 minute, you will see that the touch screen is activated and you can use it. We have an emergency button, very important, because pushing it will stop immediately the motion of the robot. All the movement will be stopped, all the brakes will be activated, so the movement of robot will stop. Emergency stop shall not be used as a risk reduction measure. Must be only a secondary protective device. So you cannot use this emergency button as a, let's say, one of the main methods to prevent collision between the human operator and the Cobot. Free drive button, it's activating the free drive mode. We'll see later what is it about. USB connector, it's necessary because sometimes you need to load some programs, to load updates into the Cobot. So all this, if the Cobot is not do not have an Ethernet communication with the all system of the plant, with the network of the plant. So in this case, you will need an USB to load, as I said, programs, commands, or maybe updates to the Cobot software. Related to mechanical installation, before installation of any Cobot, we are responsible for ensuring that all the applicable safety laws and regulations are taken into consideration and analyzed in order that any significant hazard, any significant risk to be addressed with appropriate countermeasures. Safety first is really important because the Cobot has the potential to deteriorate or to hurt the human operator. So that's why before any kind of Cobot installation, adequate risk assessment must be performed for the complete robot system, not only the Cobot itself, but for the complete complete environment where the cobot will be used. Interfacing with other machine and additional safety devices must be taken into consideration in the risk assessment. Set up the appropriate safety setting in the software. It's one of the critical elements because the cobot is coming with some safety settings or safety elements included into the soft. If we bypass them, we just create the opportunities for the accident, for the safety problems for hurting the operators. Uh, Validating that the total robot system is designed and installed correctly also it's a very critical issue. We need to design instructions to make them clear, available to the operator in order that the operator to be able to start and stop the cobot in a safety way to any time when he needs some information or some clarification to be able to identify all this information to the instructions. The robot must be supplied, must be marked with all relevant warnings or relevant details or marks or highlights. All the documentation, as I said, must to be included in a technical file, sorry, including the risk assessment. All this information must be available onto the area where the robot is working, otherwise are useless. If the operator need to check something, he need to have this folder, this file available. When we talk about mechanical installation, there are two areas that need to be taken into consideration, uh, which one of them it's at the maximum of the reach of the cobot, where even the cobot make a movement with a low speed. Due to this range, he is able to hit the operator or any other obstacles that he find uh, into the area, so can create the risk. So that's why when the area where the robot must to work it's longer than 450 millimeters. In case of this cobot, we talk about UR5. So when the cobot is going to this distance, 450 millimeters from the base, there is a risk of stretches out or to punching of the operator or destroying the obstacles that the cobot will reach. The other area is the area close to the base of the robot, where even the robot is going with low speed. Due to the fact that it's very close to the base, the force with which the cobot will hit the obstacle will be quite high. So always when we install a cobot, we need to take care of these two distances. Of course, the distance in millimeters depends on the dimension of each cobot. In this case, for the UR high, for the UR5, we have these dimensions. We have also some details about how to fix the robot onto the base. The robot can be fixed on the base, on the floor, or can be on a support in order to make him to act, to operate to a higher uh, distance from the floor. There are also some possibilities for some specific application to dramatically increase the reach of the robot by adding linear axis, vertical and horizontal, that can enhance the radius of actions many times. But in this case, as I said, we need to take care about the obstacles. We need to have a more detailed risk analysis in order to avoid obstacles, in order to avoid accidents. In terms of gripple development, there are not too many things to say. the most frequent gripper that we have into our plant and I see until now is the gripper with fingers between 2 to 5 fingers for pick and place. So because pick and place is one of the most frequent application, also the gripper for pick and place is the most frequent. We have also suction cups. We don't use them in continental CBU, but exist and can be very used with very good results. And also there are two grippers, let's say more specific for the application, magnetic, when you need to manipulate some parts made from iron, or electrostatic when you need to manipulate some, let's say, plastic parts that are able, or small parts that are able to manipulate it using this electrostatic effect. But these two, magnetic and electrostatic, are quite low frequent kind of grippers. Anyway, we have a lot of possibilities to choose. There are companies that design specific grippers for each application in such a way that uh, maximize the productivity of the cobot, maximize the task that they are able to perform in order, and completely avoiding damaging the parts of the parts that the cobot manipulate. So the gripper is designed based on these two considerations: maximum productivity, is which is coming from the easiness of picking and placing the part, and not damaging the part during the pick and place and moving of the part. In terms of electrical installations, we have also some safety considerations. Before any electrical works, we are responsible for ensuring that all applicable safety laws and regulations are taken into consideration, and any significant hazard in the complete robot application are eliminated. So we must take into consideration, when we talk about the risk, about all the elements, not only about the robotic arm or only the electrical box. Also, uh, we need to consider the system need of these three components, and also integrated with the machines, the equipments where the robot is working. Control box is the one which is connected with the main power source, and from the control box there are connections to the touch screen and to the robotic arm. Main electrical interfaces you can find in the control box. What we can find in this control box: also connection to the ground, which is really important, because due to this movement, these manipulations, sometimes electric charges can appear, or some desisolation of the wires can appear. So it's very important to have a connection to the ground. We can find on the electrical box the main fuse and connections, as I said, with the other two components of the cobot. Also, on the control box must be installed devices for lotto. We talk here about the devices for lockout, tagout, in such a way that if an operator or somebody, maintenance guy, come to make some modifications, then he will completely stop the robot, and nobody else is able to restart the robot in an accidental way. You can also find here some other connections: main connections, robot connection, controller, tool, Ethernet connections, depending mainly on the application that will be used, or how complex is the cobot, and complexity is coming from the application also. We'll find also a lot of possibility to connect the cobot with other devices. We talked earlier when we said about the applications that sometimes the cobot need other devices like cameras, like force detections, or when you put in at the end of the robotic arm, you put a gripper that need to have some power supply or need some control. Uh, all these elements are, let's say, connected also inside the control box to and allow us to use or to design the application that we need for our plant, for our shop floor. Related to software, when we talk about the software, universal robots use the polyscope. This is the name of the program that you'll find into the touchscreen and the operate, which is interface based on Linux, and it's the property of the Universal Robot Company. They develop it, they keep it updated, and it's, let's say, with copyright. And what I can say is that it's very easy to use this interface. It's very intuitive. Related to the manipulation or using of the robot, there are several modes that the robot can be. We have, first of all, the normal mode. The cobot, it's doing his task. He's running. Effectively, he's running in a protective mode with safety limitation, uh, and it's realizing the task in the design cycle time with the designed specification. This is most of the time the robot is operating in this normal mode. Then we have the reduced mode when the tool center point, which means the center of the gripper, is positioned beyond a specific point designed in such a way that Cobot knows that he's out of the area where it's allowed to work. So actually we define some protective plan, and the Cobot knows that don't is not allowed to go beyond that plan. So when we force him to go to the other side of this plan, he will enter in the reduced mode in such a way to reduce as maximum the possibility to hit some obstacles or to hit somebody which is on that area. Recovery mode, it's when the robot is outside allowed area. This mode allows the robot to move slowly back to the area where it has the permission to work, to operate. It's very important, these two ways. We can define into the software of the robots, we can define some areas where it's not allowed to go with the robotic arm or to the gripper. And by these two modes, the cobot reduce as maximum possible the risk for accidents, the risk of punching or hitting the operator or other obstacles. We have also free drive mode. When the cobot is in the free drive mode and the movement goes to the limit that we talked earlier, the user will see a repelling force. So the cobot start to uh, oppose, to try not to go outside of the area which is allowed for him. So the operator, the person, the user will see this force closing higher, closing to the position, to the limit position. But despite this, if you really force him, push him, the robot arm will go outside allowed area. This is more as a warning. So when you design the movements of the cobot, and there is a certain plan, because outside that plan there are some time to time obstacles, and you try to program him to make some movements into that area, the robot will give you a feedback that he is not allowed, it is not allowed to operate on that area. Backdrive mode can be used to move specific joints to a desired position without releasing the brakes. When we want to teach him to move to some movements, some applications, sometimes we need to put the robotic arm into a very tight position. So in that case, we need a more precise movement. So we just keep the brakes of the robot closed. So we move him slower, but with higher precision. This is why we have this backdrive mode. And that's it about our cobots. In Continental, we have somewhere between 50 and 100 cobots running. I don't have exact figures because the number, it's depending on the application that we need, we run at a certain time. Thank you for your attention. If you have questions, please ask.
Thank you very much for your presentation. I have one question, of course. If you send more, I will forward them. This one question is, on the previous slide, you mentioned those two modes, so the free drive mode and the backdrive mode. Do you often use them, or is it something just for the safety purposes and you don't really happen to use them in the real life scenarios?
We use free drive mode because we have applications where we have two cobots on the same cell. So the cobots are working on the same workspace. So we need sometimes to define that one cobot do not enter into the area of the other one. So we define a safety plan between them. So if you try then to teach the robot to do some applications, to take one part to put it in a other way, and you are coming close to this plan, you don't see it as a human that or user, but the robot knew about it, then the cobot is giving you a feedback, a warning. Take care, you are coming closer to my restricted area. So we really use it, free drive mode. And backdrive mode, as I said it, when you need to position very close, with very high precision, the arm in a certain position, it's easier to do it with these brakes released than without, because if the brakes are not released, you just move the arm of the robot like how you move your hand. Very easy, very with no opposition from the robot. You see the wheels rotating there, but the cobot is just really moving very slowly, very easy. When you need to fix it in a very close position, less than 1 millimeter, then you just put him you bring the arm close the position, release the brakes, and then go step by step very close until you reach the desired precision of the let's say tolerance of the applications. So yes, we use both of them in real life.
Thank you very much. I don't. Yes, I see additional question. It is question from ULBS. Do you have application with two or more cobots directly interacting robots, like working with two hands?
At this moment, no, we don't have the applications into the shop floor. We have the applications only in our laboratory. We have we call it Smart Application Shop. It's a laboratory where we design prototypes, and there we succeed to, let's say, one cobot take a piece from a box, give it to the other, and the second robot put the part in other box. yes, we succeed to do it in laboratory, not in the production. Until now, we still have a lot of applications that they require only one robot. We are focusing on this. Now, for the moment, is not useful. We do not have application for 2 robots because there are on the list, on the waiting list, too many other applications that require only 1 robot. So for the moment, we don't have it. As I said, we have it as a prototype, really running, very nice running, because both robots have cameras. It's really nice working, but not on the shop floor. Related with other kind of robots, it's a corporate decision. It's not a local decision. We would like to test more robots with other speed, other payloads maybe, but for the moment, we need to work with universal robots. It's a corporate decision, so we are in from this point of view, because I know there are faster robots than universal robots, which can be used for small distances. There are robots, cobots, that can handle for a higher distances. But for the moment, this is a corporate decision and is not allowed. Even if we would like to, we can't at this moment.
Okay, I don't see any more questions. So I would like to thank you very much for a great presentation and invite all of you to the next webinar, which will also be about cobots and will also be done by Continental. So have a great day. Bye-bye.
Bye-bye. Thank you very much.
Thank you. Bye-bye.
Bye-bye. Thank you very much.
Thank you. Bye.